Hello. So in the previous example, we used a 4-resistor network to bias a MOSFET. And since we had centered the gate, we could use this also to create a common drain amplifier, also known as a source follower. If we insert a signal here at the input, and we take the output at the source, we have a source follower or a common drain amplifier. Now, when we do that, in order to have maximum swing, we can discard the RD and we take the voltage at the gate, the input at the gate, and the output at the source. They are in phase, the gain is approximately equal to 1, and we can use this as an output stage in discrete MOSFET transistor applications, because as we saw in the previous video, the common source amplifier has a high output impedance, which we want to lower. So if we do DC analysis or an operating point analysis, the capacitors are all open. And so what is the voltage at the gate in this case? We expect 10 volts with a voltage divider of 10 meg and 10 meg gives us 5 volts. 5 volts. We had already done the analysis before to see that the voltage at the source was going to be 3 volts, and 3 volts over 6K gives us the 500, the 0.5 milliamps for the bias. Okay, so let's do a transient analysis and verify that if we take the output at the source, this is equivalent to the emitter follower in BJT technology, or the common collector amplifier, meaning the input is at the gate, the output is at the source, we have no gain, in fact we lose a little bit of gain, it's less than 1. Oops, let's run the transient analysis. So we have an input of 1 volt, and our output is slightly less than 1 volt, but we can drive loads that are much lower than what you will be able to do with a common source amplifier. So this can be used as an input stage or as an output stage.